Hey guys, my name is Jason with Mount Baker Mining and Metals, and in this crucible I have a bunch of miscellaneous gold beads, and on today's video we're going to refine them all down to a high purity gold button. Here's the stuff we're going to be working with today, and this is gold buttons from miscellaneous experiments and samples I've run in the past. And what I want to do is use some wet chemistry to get these refined down into super high purity gold button. But first let's take a look at the highlights, kind of where I got this stuff from and how I processed the gold ore to get these gold buttons. We're going to turn these 2 bags of rusty old rocks into nice shiny yellow gold. Alright guys, we got our concentrates here off the shaker table. There's our little bit of number 1 in there. And then here's our high grade number 2, so we got quite a bit more volume here. But most of our gold's in the number 1 here. So what I'm going to do is I'm going to pan this out, recover as much free gold as I can, and then I'm going to take the rest of the stuff, the panning tailings, and I'm going to smelt them down and see how much gold I lost in my panning. All right, so I got our gold panned out here. There's our gold. We got all our gold sucked up in our snuffer bottle there. And now I'm going to take the gold and put it in this rag. It's just a blue shop rag. Here's our gold in our rag. And now I'm going to take our rag, pull it up, and I'm just going to wring the water. And there you go. It might be hard to tell in the video, but it's pretty shiny yellow, so there's not a whole lot of silver in there. Ends up weighing about 19.25 grams. And those bags are somewhere probably around 1.5 tons, maybe 2 tons. So we're somewhere in the range of 10 to 15 grams a ton with that stuff. Now let's go and smelt the stuff I panned out. I'll heat them up to about, 800 or 1,000 degrees Fahrenheit for about 10 minutes. And get them roasted, drive off all that sulfur, and then we'll smelt them. All right, so we got our lead button here. I'm going to put it in one of these Cupels, and I'm going to put it in our little electric furnace and drive off the lead and see what kind of precious metal button we got left. This little button is the stuff that came out of the #1 panning tailings, the stuff that I panned out. That's the gold that I lost. Altogether in the #1, we ended up with about 21 1/3 grams. And then I took some of the #2 high grade that we had and smelted 300 grams of the #2 and ended up with this little tiny bead here, which weighs right around 1/10 of a gram. And I've dried out and weighed the rest of the #2 concentrates, and I have about 3 kilograms of that stuff. So multiplying this number by 10, there's about a gram left or so in the #2 high grade. Now that we know where these came from, let's get them all weighed up, figure out how much gold alloy we have, and then we can work on getting them refined down. 54.3 grams. And so now I got to mix all this gold up with silver to get it down to about a 25% gold, 75% silver alloy. Here's the quick math part. So we have 54.3 grams of about 90% gold alloy. So we're expecting about 49 grams of gold. To mix it up and get 25% gold, 75% silver, we're going to divide by 25%. We need almost 200 grams total. So when you subtract our total from the amount of gold we have, we need 146.61 grams of silver. Did anybody else see my mistake? I caught myself. I don't need to subtract the 48 grams of gold because I have this much. So if I subtract the 54.3 grams of gold and silver alloy that I have, I only need to add in 141.18 grams of silver. So that's our next step. Here's the silver I'm going to use. I'd made this years ago on an old video, and if you're interested, I'll put the video on how I made this silver at the very end of this video. It's from old film. I recycled some old film canisters, I don't know what they're called, and recovered this silver. So if you want to see where the silver came from, check it out at the end of this video. But I have 745 grams of silver, and I only need 141. So I'm going to melt this down in the furnace, pour it into water, cornflake it, and then we can separate out about 140 grams of silver and leave the rest as cornflake silver so we can use it in the future. Put our silver in a fire clay crucible, so we'll bring it over here, put it in our furnace, and get it melting. That worked pretty well. I poured it a little bit fast, but we did get some nice silver cornflake there. I got a few pieces that kind of stuck together like that, but that's okay. We'll use up these big pieces since we're just trying to get the right amount of weight rather than the surface area for this next part. There, we'll use that. There we go. Get the flame going again. And we'll do the same thing, cornflake it in water. I've got our stuff all cleaned up, and I have a little bit of a concern here. I don't know if you can tell on the camera, but if you look down there, there's some pieces like over here and up in here that are a little yellower, and a lot of it's silver. Do those pieces contain more gold than like this big chunk here that's all silver colored? Because if they do, that's going to be a problem. We need it to be all uniformly mixed 25-75 so the acid can eat the silver away, and the silver, there's enough silver atoms to give the acid room to get in and eat around essentially every gold atom and clean it up and get all the silver cleaned up. But we're gonna go ahead here and see what happens if we get it screwed up. I can always redo it because I have a bunch of shot silver here. So I'm gonna add 100 milliliters of distilled water. Roughly, that's about 150 because there's silver in there. Now I'm gonna go put my respirator on and add another 100 or so milliliters of nitric acid, get it heated up, boil it, it'll dissolve the silver and leave us with the gold sponge. The silver's starting to turn brown already. And the nitric will dissolve the silver but leave the gold. And the heat speeds up the process. All right, well, our first boil is pretty much complete. A little bit of gas still coming off, but I've got it on the upgraded burner here. So I'm going to just decant the solution off. Now I'll add more water and more nitric, and we will continue the reaction. Well, I've got some pieces in there that are still silver colored. This is the third boil. There's hardly any gas coming off and the solution's pretty much clear. So I think what happened was I didn't mix up my gold silver alloy enough, and those pieces in there have so much gold in them that it's not allowing the acid to get at the remaining silver. So there you might be able to see them a little better. They're just not reacting with the acid at all. I think they have a film of gold on them essentially. So we'll melt it back down. Try again. Well, there's our gold. I'm going to wait for that to cool and then I can pull it out of there and dunk it. We can get a weight on it. Here's our melted gold button. We get a weight on it, but you can clearly tell that there's still a lot of silver in there. It's not very gold colored. There you have it. We've gone backwards. We've got more silver in there now than when we started. Okay, let's get that back in there and cross our fingers. Well, that definitely looks better. It's all more uniform color. There's a little bit of flecks of slag on there and stuff. I don't know if you can see them there, but it's all nice and shiny silver color. So I think we've got our alloy mixed up pretty well. So now we can repeat the nitric acid baths. We're back on the heat. I'm recycling the last nitric bath I did since there was hardly any nitric used. So hopefully we can save a little bit of time and money there. Now we can take our spent nitric and silver solution here. I have a bucket with some copper pipe, and I can pour this in here, and any silver dissolved in this solution will plate out on the copper pipe. The silver's plating out on the pipe, and so the copper will go into solution as copper nitrate, and you'll have silver sludge in the bottom here. So that's how we can recover our silver. Here's a look at our second boil. There's no more gas coming off. The solution is clear because there's no copper in there. And it looks a lot better. I don't see any silver pieces, or it's all turned brown at this point. There you go. See, it's all just nice brown gold mud essentially. So we'll do one more boil and see what it looks like. Well, this is our third boil, and at the beginning it made a little bit of brown gas, but hardly anything, and now it's just absolutely clear. The solution's clear. There's no gas coming off. All the mud in the bottom is a nice brown, a little bit of orange color. So we have gone to completion on our reaction. Now we have our gold mud. I'm going to filter it through my funnel here. There's our filter paper, a little bit of borax on top. Let's see how we're doing here. Oh yeah, we're melting down nicely. It's almost all molten there. All right, we are completely molten now. There's a little bit of bead of borax on top. I'm gonna try something different. What I'd really like to do is get a nice finish on the button. So I'm gonna add some more borax right on top and see if I can completely cover the surface of the button with borax and then let it cool down and see if I can get a nice mirror finish. So you probably can't tell, but the button is now covered in borax and it's molten. So now I'm just gonna turn off the furnace. I'll let it heat back up just because. But then I'll turn it off. We're gonna sacrifice that melting dish, but hopefully we get a perfect mirror finish button. Well, I've turned it down to about 1800 degrees to keep the borax molten. The gold should be solidified now. Yeah, gold solidified. So let's see if I can take it. Come on. Nope. That didn't work very well. My surface is not like I wanted. It's still kind of pockmarked. And it's covered in borax. And now it's stuck to the melting dish. So that's not the best way to do that, but hey, we got our gold bead. Let's get it cleaned up and see how much it weighs. Let's sacrifice our melting dish here. Oh boy, that welded on there real hard. Okay, don't do it this way. So look at that, shrinkage on the top and shrinkage on the bottom. It just sucked it right up from the bottom, sucked a bunch of borax under there. So you can't, I guess you can't cool it down slowly. You gotta just pour it into an ingot mold or something, and that's how you get a good finish. Well, this is the best way I know how to clean all that borax and junk off of there, is get about 100 milliliters or so of water, and then add some of this sulfuric acid to it. Maybe another 20, 30 milliliters. And just let it boil for a little while. That'll eat up all that borax and stuff on there and give us a nice shiny button. Okay, let's have a look at our bead here. Get it rinsed off. There we go. Nice purified gold bead. And now the fun part, where we're looking for somewhere between 48 and 50 grams, I think. 50.9 or so. So that's a little bit more gold than I was expecting. But it's all one piece now, nice shiny color. We're going to be smelting down some silver from some of this old film canister stuff. The solution comes through here. There's typically an iron mesh in here like steel wool. And as the silver solution comes in, it replaces silver onto the steel mesh and the iron goes into solution. So hopefully we can get quite a bit of silver out of this stuff. This is just anhydrous borax, so I'm going to mix that in. You just hold it right there and I'll pour it. So yeah, there's your hot lava. Yeah. And all our silver's right down there at the bottom of that cone. I've got all our cornflake silver in a number 12 crucible, and I've added a whole bunch of potassium nitrate, and I'm going to try and oxidize some of the iron out of there. All right, guys, let's see what we got here. So there's our metal block. So now we got to take this and get our pure silver out of it, get rid of the lead, get rid of the rest of the iron. I'm going to get some Portland cement, and I'm just going to make a little dished concave bowl here out of Portland cement, and that's going to absorb the lead oxide when it gets molten and starts running off that bead. Okay, there it is. We'll see if this works. That looks like it'll hold about 1 kilogram of silver. We're gonna find out. So there's a little silver wafer down there, and this was not as easy as I thought it was going to be. You can see all the little beads of silver around the edge. There was a huge amount of iron in there, and it took me forever to get the iron oxide scraped off, to get the lead exposed, to start driving the lead oxide and any other little base metals that were in there. You can see what came out, and here's a cross section of what that looks like, and that silver wafer sitting, right here on top, and then the lead oxide has permeated into the Portland cement down there, maybe 1 inch. All right, there's our used up Cupel. Here's our little silver wafer. There's still some junk in the back. I'm going to take this and melt this down. All right, I got our 3 things in here. I've got the silver and a little bit of borax down the bottom of that crucible there. I've got our iron oxide skimmings from the Cupel. And then I've got our Portland cement with a bunch of those little silver beads in it with some borax, and that has borax and a little bit of soda ash in it. All right, here's our silver block. And here's our silver block all cleaned up. Let's see how much he weighs. Right about 750 grams. So that's pretty cool. So I hope you guys enjoyed the video. Thanks for watching, and we'll see you on the next one.